In this video, we're just going to define some terminology that we'll be using a lot, especially as we start to do experiments regarding thermodynamics. So you will hear me use the word system a lot to describe whatever it is that we're studying. So it is the region of space or substance that we are interested in studying. So it's whatever we're investigating. In our experiment or calculation, whatever we're doing at the moment. So the system is generally one small portion of the universe, either an area of space or a substance, a particular sample of a substance. The surroundings is defined as literally everything else. So the thermodynamic definition of the surroundings is actually the rest of the universe. So this is very literally the rest of the universe except for the system. So whatever is not part of the system is part of the surroundings. So the universe can always be thought of as the system plus its surroundings in thermodynamic terms. So when we're dealing with heat transfer, we're often thinking about the transfer from a system to its surroundings or vice versa. So you always want to kind of have in mind what exactly is my system here and what is the surroundings. Sometimes it doesn't matter too much how you define it. And we'll talk about that more as we go forward and see specific examples. But there are also a few different types of systems in thermodynamics, depending upon what is able to enter and leave the system. So there are three different types of systems: open, closed, and isolated. So an open system is what you are most used to working with. An open system is very literally open, that both matter and energy are able to enter and leave the system. So something like just a beaker that you're doing a chemical reaction in. If you do a chemical reaction and it produces a gas in an open beaker, that gas is going to escape, and that's matter leaving your system, if your system is whatever is in your beaker. So an open system is one where both matter and energy can enter or leave the system, can be added or removed. Open systems are not really useful for thermodynamic study because the amount of matter in them is not really constant. That if the amount of matter isn't constant, the amount of energy being transferred into or out of the system isn't really as easy to measure and isn't as meaningful if we can measure it. A closed system is one where matter cannot leave, so atoms and molecules can't come in or out, but energy can. So matter cannot enter and leave a closed system. But energy can. So take your beaker and cover it with something, or take a bottle and close it on the top. If something is airtight, matter can't get in and out, but energy can still flow through it. If you cover your beaker and the stuff inside is warm, you can still feel that heat through the beaker. That energy is escaping through the walls, even though atoms and molecules can't go in and out. So the last one is known as an isolated system, which is one in which neither matter nor energy can go in or out. So the total amount of matter and the total amount of energy inside are constant. In practice, truly isolated systems don't really exist. But for the purposes of thermodynamic study, we try to mimic an isolated system by creating a closed system that is really heavily insulated. So if you use a really well insulated container and it is closed to the outside, so matter can't get in and out, and energy transfer through the walls is minimal due to the insulation, we can kind of mimic an isolated system. Technically, a little bit of energy does still get out no matter how well you insulate it. But that is usually what we're trying to do in most thermodynamic experiments, and we'll see that soon in upcoming lessons, how we go about that. But when we're doing thermodynamic calculations, a lot of the time we have to assume that we're working with an isolated system in order for the math to work. So we want to mimic that as closely as we can in the lab, and we do that by using heavily insulated containers. We'll be using a thick styrofoam container that contains the heat pretty well. So all three of these things are kind of important to recognize the distinctions. If you're working with an open system, you can't really study the thermodynamics effectively. In thermodynamics, we're usually actually working with a closed system, but we want to try to get it as close to isolated as we can.